Okay, so first things first, I really want to double check and make sure that none of you distributed that cube to both of these terms. Remember that if there's an addition or subtraction in between the two terms, that you cannot distribute that exponent into the parentheses. You have to remember that that is root 2 minus root 3 times root 2 minus root 3 times root 2 minus root 3, right? So you have to distribute that all out in order for it to be correct. So if you just did root 2 cubed minus root 3 cubed, no, don't do it. Wrong choice, okay? That is not something you can do. That is considered a pretty rookie mistake at this point, and that's kind of a big deal. If we start to see that on a test, we get a little nervous, okay? So that's something that we need to kind of nip in the butt right now. You cannot do that if you have an addition or subtraction between two radicals. So if you did that, just be really wary. That's a big mistake. So let's try and make sure to not do that on a test. Okay, so how we could solve this is you could FOIL out two of these parenthesis terms together and then double distribute in this guy at the end. Or we can try and use our handy dandy Pascal's triangle to help us with the amount of work that we would have to do. If you remember, a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So since this is something that's being expanded out in that way, we can follow that same process. This is going to be that a is equal to the square root of 2. Careful here because there's a minus. B is going to be equal to negative square root of 3 because this only accounts for addition. It does not account for both addition and subtraction. Remember our sums and differences of perfect cubes, how it didn't really matter, or you don't assign A or B in your sum or difference of perfect cubes as a negative, because depending on whether it's a subtraction in here, you would be using a different formula. Here we only have one formula and it counts for addition here, which means then that you need to make sure that if there is a subtraction, it means that that last term is negative. So just be wary about that. Now that I know what my A and B are, I'm just going to plug them into my Pascal's triangle. So I've got A cubed, which is the square root of 2 cubed, plus 3 times the square root of 2 squared times negative square root of 3, plus 3 times square root of 2 times negative square root of 3 squared, plus, and then we've got negative square root of 3 cubed. All right. Square root of 2 cubed, you can think about in many different ways. You can think about bringing that cube inside of the radical, which you're totally allowed to do, that you can then make it 2 cubed, which is 8, and you would have the square root of 8. Notice that a perfect square does go into the square root of 8 because 4 goes into the square root of 8, and that comes out to become 2. Or you can think about it as the same thing being multiplied by itself 3 times. It's the square root of 2 times the square root of 2 times the square root of 2. 2 of those square roots of 2 would multiply together, and the square root of 2 times the square root of 2 is 2. So both of those would multiply down to become 2, but you still have one more square root of 2 left. So then this would just become 2 square root of 2, which we saw up here. It's just a different way of thinking about it that might make it a little bit easier. Plus, then we've got 3, and then square root of 2 squared is just 2. So it's going to be 3 times 2 times negative square root of 3 plus negative square root of 3 squared. That negative now becomes positive. Square root of 3 just becomes 3. I'm going to multiply it to my 3 out here, and I've still got a square root of 2 hanging on. Negative square root of 3 times negative square root of 3 times negative square root of 3. There's two things that are going on here, the negative aspect and then the square root of 3 aspect. The square root of 3 aspect is going to follow the same pattern as the square root of 2 piece, where it's going to be the square root of 3 times the square root of 3, which just becomes 3. You've still got one more square root of 3, so it becomes 3 times the square root of 3. Now, with the negative piece, a negative times a negative would be a positive. But if you multiply a negative in there again, now it becomes a negative. So then this becomes minus 3 square root of 3. So recapping, negative times negative times negative is a negative. Square root of 3 times square root of 3 times square root of 3 will multiply to become 3 square root of 3. Okay, so I'm going to do a couple things here all at once in this last step. I'm going to multiply these coefficients together as well as combine them with their like terms. The like terms here are the square roots of 2 and then the square roots of 3. So 3 times 3 is 9. So I'll have 9 square root of 2 here and 2 square root of 2 here. So it's going to be 11 square root of 2 total. And then 3 times 2 is 6 times negative 1 is going to be negative 6. Negative 6 minus 3 is going to become negative 9 square root of 3. Okay, last problem. So we want to simplify something that looks like this. And there are a few implications here that we have to take into consideration when we're being asked to simplify an expression that looks like this. At first, you might look at this and say, I don't really know what to simplify here. I hope that it's by now you'll have recognized that this is something that we've done in the past. And the thing that I do want you to notice is that it tells you to simplify it when it seems unsimplifiable. So it's implying to you that there's something hidden in here that you need to pay attention to. If we can simplify this massive square root, that means that whatever is inside of the square root has to be a perfect square. It does not mean that 49 is a perfect square, so now that becomes 7, because there's a subtraction in between. So this addition subtraction piece always messes up what your original plans are. But that means that there is something that is a perfect square such that it would simplify out to become, it would simplify out of the square root. So that means that this guy right here is some sort of perfect square, and we need to know that what is the thing squared that is 49 minus 12 square root of 5. So I'm going to expand out what is a plus b square root of 5 squared and try and do my equality of surds piece that I did up above, like on problem D, to figure out what would give me 49 minus 12 times the square root of 5. So a plus b square root of 5 times a plus b square root of 5 has to be equal to 49 minus 12 square root of 5. In order to simplify this down, what's ever inside has to be a perfect square. So we just need to find out what is the square root of this guy. Okay, so that becomes a squared plus, that's going to be a b root 5, a b root 5. So now I've got 2ab square root of 5. And then that's going to become 5b squared. I'm going to put my non-square root terms together. So that's going to be a squared plus 5b squared plus 2ab square root of 5 equals 49 minus 12 square root of 5. So again, I'm combining terms that are going to match up with my 49 and my negative 12. So now that I've done that to make it into this grouping of things that I know are going to work well together, that I'm going to be able to match on either side, I now can do that matching and say that I know that a squared plus 5b squared must be equal to 49, and that 2ab must be equal to negative 12. I'm going to divide both sides by 2, so I get ab is equal to negative 6. Okay, so we want to find two terms that multiply. I'm going to just think about 6 here for a second because I know that I'm going to be squaring both of those terms. And so I know that no matter what, whichever one's negative is now going to become positive. So I really just need to think about positive 6 here, and then I'll think a little bit later about how this negative then plays into my idea of what's going on here. The options are 1, 6, 6, 1, 2, 3, 3, 2. If I did 36 here and multiplied it by 5, I know that when it works, so I know that the first guy is out. If I did 36 here plus 5, because that would be 1 squared, and then 36 plus 5 would be 41, which is actually the first time we've encountered something would be less than what we want it to be. So then that wouldn't work out. Trying 2 and 3, I would get 3 squared is 9 times 5 is 45 plus 4 would be 49. So that's me doing it in my head, but you could always just double check by doing 2 squared plus 5 times 3 squared. So that's 4 plus 3 squared is 9 times 5 is 45, and that is 49. So it looks like this guy is the one that works. We can just really quickly double check this guy because it doesn't take too much time. That would be 9 plus, and that would be 4 times 5 is 20. So then 9 plus 20 is 29. So that wouldn't work because it would be too little. So this is our solution, that A equals either plus or minus 2 and B equals either plus or minus 3. We know that it then has to be a negative 12 here at the end. I'm going to try out doing 2 minus 3 square root of 5 to make the B a negative 3 and see how that turns out. Double checking for the negative here. Oh, sorry, not square root of 3, square root of 5. I bet some of you are confused there. So I figured out that I knew that A and B needed to be either 2 or 3. And then I need to go back and figure out which one's going to be negative in order for it to work out that I've got a negative 12 here. So if I tried out 2 minus the square root, or minus 3 times the square root of 5, I get 4 minus 6 square root of 5 minus 6 square root of 5 plus 9 times 5, which then gives me 4 plus 45, which is 49, minus 12 square root of 5. And that guy works. So that was what my hunch was that the second term was going to have to be negative. And so I just tried it out, and it's true. So now I know that this guy simplified. So I wouldn't say that A equals 2 and B equals negative 3 here. Remember that what we're originally asked to do is to simplify this radical. And the simplification of this radical is that it is equal to 2 minus 3 times the square root of 5. Taking the square root of this term gives us 2 minus 3 root 5. This guy right here is probably one of the hardest problems that you're going to have on the test. So if it's something that you're stressing out about, you can always rewatch this. You can always try and notice previous problems that have been leading up to this idea, like D here, like the last problem on our last notes, and see if you're understanding those steps. We're going to have check for understandings that are going to give you more practice on it. So there's lots of options here.